Hi, good afternoon, Madam Liu. Today our group will make a presentation about differentiation. Before that, I would like to introduce the member of the group. First, we have Daniel Hakim Ben Suhaimi, registration number 10DKM22F 1078. And then we have Shual Azmin Ben Nizam, 10DKM22F 1079. And then Muhammad Wafi bin Nasrul Hisham 10 DKM 22F 1085. And then Ahmad Adi Shawar bin Ahmad Ridwan 10 DKM 22F 1065. Uh, First of all, I would like to tell about a task carried out by our group member. Shual Azmin bin Nizam helped the team on answering the question. And then Hakim bin Suhaimi made the slide and did some research. Muhammad Wafi helped with finding information about differentiation. And then Ahmad Adi Shawal helped Suhail on sketching the graph for each question. And then I would like to talk a little bit about the differentiation. What is differentiation? Differentiation is a fundamental concept in calculus that involves finding the rate of change of a function. It is an it is an essential tool in mathematics, science, and engineering, and is used to model and analyze a wide range of phenomena, from the motion of objects to the behavior of complex systems. Differentiation is also the process of calculating the slope of a function at a particular point. It allows us to understand how the function of changing at the point and to make prediction about its behavior in the vicinity of the point.
So, right now I'm going to tell you about the applications of differentiation in real life. Differentiation can be applied in numerous aspects in real life, from learning in school to using in optimizing rate of change in a physical system and also optimizing business. Here are some examples on how we can use differentiation in real life. First is physics. Differentiation is used to calculate the velocity and acceleration of objects in motion by taking the derivative of an object's position with respect to time. We can determine how quickly it is moving and how its speed is changing over time. Next one is engineering. Engineers use differentiation to design and optimize systems such as engines, turbines, and control systems. For example, they might use differentiation to determine the maximum power output of an engine or to optimize the control of a robotic arm. Next is economics. Differentiation is used to analyze the behavior of financial markets and to optimize business operations. For example, economics might use differentiation to model the impact of interest rates on investment returns or to calculate the marginal cost of producing an additional unit of product. And lastly, biologists use differentiation to study the growth and development of organisms, such as the rate at which cells divide and differentiate into specialized tissue.
So moving on to our first question, y equals to minus 3x power of 3 plus ax squared minus 5. Afterwards, we need to differentiate the equation to get minus x squared plus 16x. We need to factorize the equation so we can get 2 points, which is 9x minus 16 and x. So we can use this factorized equation to find the stationary points. So by doing dy dx equal to 0, the equation will be 9x minus 16 equal to 0, 9x equals to 16, and x will be equal to 16 over 9. And then x equals to 0. By substituting the equation into the first equation, we will get the answer here by doing all the work here. We will get the answer 833 over 243. So by substituting x equal to 0 into the first equation, we will get, again, by substituting x equal to 0 into the first equation, we will get the answer for y is equals to -5. After we get all the points that we have, we will get two stationary points, which is 1.78, which is from x equal to 16 over 9. We turn it into decimal. Same goes with 3.3, which comes from 833 over 243. We turn it into decimals. And then that is for our first point. Now we got our second point, which is x equals to 0. And then the y is -5. So the graph have two stationary points. Next, we are going to find the x-intercept, so we have to make it y equal to 0. Insert into the first equation. So by inserting the values into the calculator, here we got x1 equals to -0.7, x2 equals to 2.37, and x3 equals to 1. So the coordinates will be -0.7 for x and 0 for y, 2.37 for x and 0 for y, and 1 for x and 0 for y. To find the y-intercept, we have to do x equal to 0, and we insert it to the first equation, y equals to -3. So yeah, as you can see here, the x is 0, we insert it into the equation, and we get y equals to -5. So the coordinate will be 0 for x and -5 for y.
So for the equation 5, we need to differentiate again the previous equation. For example, the previous equation is -9x squared plus 16x. Therefore, the differentiation is -18x plus 16. Then we need to take the value of x and turn it into like this. So it will be x equals to 16 over 9. Then we need to put the value of x into the second differentiation. So it will be like this, -18 in the bracket, -16 over 9 plus 16. Then after we do the equation, the final answer will be -16. Since -16 is less than 0, therefore it's a maximum point. Then for the second point, we need to make the x equals to 0. Then differentiate it again, and the answer will be 16. Since 16 is more than 0, therefore it is a minimum point. At the end, when we put all of the values in the graph will turn out like this.
Question H. Given the equation y equal to -4x power of 3 plus 2x squared plus 5x minus 1. Now we need to differentiate the equation. So the answer we will get -12x squared plus 4x plus 5. Now after we differentiate the equation, we need to factorize the answer. We will get 6x minus 5 and 2x plus 1. Stationary points. dy over dx equal to 0. Take this equation and equal to 0. 6x minus 5 equal to 0. So the answer we will get x equal to 5 over 6. Do the same thing at 2x plus 1. Next, substitute x equal to 5 over 6 into equation 1. Equation 1 is this, y equal to 4 in bracket 5 over 6. Now substitute x equal to 5 over 6 into equation 1. And after we calculate the final answer, we will get 229 over 54. Jump to the game, or what? And next, substitute x equal to -1 over 2 into equation 1. And after we calculate, we will get -5 over 2. Therefore, stationary points is 5 over 6, 229 over 54, and -1 over 2, -5 over 2. Now, to find x-intercept, y equal to 0, -4x power of 3 plus 2x squared plus 5x minus 1 equal to 0. Put the equation in calculator and the final answer we will get x1 equal to -1, x2 equal to -1.31, and x3 equal to 0.19. For coordinate, we will get -1, 0, 1.3, 0, and 0.19, 0. To find y-intercept, x equal to 0, and put the equation in calculator and we will get the final answer y equal to -1. For the coordinate, 0, -1.
dy over dx equal to -12 x power of 2 plus 4x plus 5. So we -12 times power of 2 power, and we get -24x plus 4 at the point x equal to 5 over 6. So we can get a negative 120 over 6 plus 4 uh, equal to -20 plus 4, and the answer is -16. Since -16 is less than 0, therefore it's a maximum point. So dy over dx equal to -12 x over power by 2 plus 4x plus 5. So we multiply the power of 2 and we get a -24x plus 4. At the point x equal to -1 over 2, we insert the value of x. So -24 times -1 over 2 plus 4. The answer is 24 over 2 plus 4, and the last answer is 16. Since 16 is more than 0, therefore it's a minimum point. Okay, this is a graph for our calculation. Overall, differentiation is a powerful mathematical tool that is essential for many areas of study and research. It provides a means of analyzing complex systems and understanding the behavior of various phenomena in the natural world.
Before we did our presentation, we gathered a question from our classmates regarding problems about differentiation. Now let's move to Q&A session. Question number 1. Why is it called differentiation? The etymological root of differentiation is difference, based on the idea that dx and dy are infinitesimal difference. Now let's move to question number 2. How can we use differentiation in mechanical engineering? Mechanical engineers use differentiation to study the motion and behavior of physical systems. By differentiating displacement, velocity, and acceleration, they can calculate the force acting on a system and design components that will withstand those forces.
Now, the final question, other than mechanical engineering, what are other things that we can use differentiation? Chemical engineers use differentiation to analyze thermodynamic systems such as heat exchangers and refrigeration cycles. By taking derivatives of temperature, pressure, and other thermodynamic variables, they can optimize the performance of these systems and minimize energy consumption. That's all from us. Thank you so much.